Everyone, and welcome to the last video of the product and quotient rule. And in this last video, we're going to use the quotient rule to help us derive the last four trig functions. Recall from a previous lesson that we've already talked about the derivative of sine of x is equal to cosine of x. And the other derivative that we already know so far is that the derivative of cosine of x is negative sine of x. So we're going to use both those derivatives and the quotient rule together to help us do the other four trig functions. So first one we're going to look at is tangent of x. And if you remember from trig, anytime you want to try to simplify something, one of the general rule of thumbs is when in doubt, change everything in terms of sine and cosine. So one way that I'm going to rewrite this before I take the derivative is instead of tangent x, it's going to be sine of x over cosine of x. So we have a quotient, and that means we can use our quotient rule. So taking y prime, we're going to do low d high, so that's cosine x, that's our denominator. D high is going to be cosine x again, minus, and then high d low. So sine of x, derivative of cosine is negative sine of x. That's all divided by low squared, so this is going to be cosine squared of x. So obviously, as I talked about in the other videos, simplifying is important when it's going to yield a better result than this. We know that we can multiply some things together, and looking in that numerator, we have a very good trig identity that we can use here. We're going to have cosine squared of x. It's negative sine x times negative sine of x is positive sine squared of x. And what you should hopefully see there in the numerator is that we have a Pythagorean identity. So cosine squared plus sine squared is just equal to 1. And so our derivative is going to simplify to a really nice 1 over cosine squared of x. And to even go one step further now, we can say that that's going to be secant squared of x. So our first derivative rule, or I should say our third one now, is that the derivative of tangent of x is going to be secant squared of x. A very similar proof to this is for cotangent of x. And so what I would like you to do right now is pause this video and try to rewrite cotangent as a quotient and run through the quotient rule and see what you come up with. So here's the work for the derivative of cotangent. So as you can see, it's a very similar quotient rule. Instead of getting sine squared plus cosine squared in the top, though, we get negative sine squared minus cosine squared. So the best thing to do here is factor the 1 out. You can use that Pythagorean identity again, and we end up with negative 1 over sine squared of x. And so the derivative of cotangent is going to be cosecant squared of x. So we have now 4 trig derivatives. We have 2 more to go. Let's move over and work together to find the derivative of secant. So again, change everything in terms of sine and cosine. So my recommendation is secant can be written as 1 over cosine of x. And so now we can begin the quotient rule once again. This one's going to be a little bit easier than the last one because when we do low and we get d high, derivative of a constant is just going to be 0. So that entire first term is going to wipe out once we finish up this quotient rule. So low d high minus high, and then d low is going to be negative sine all divided by cosine squared of x. So that first term, like I said, cancels out. So we're going to have a positive sine of x over cosine squared of x. Now again, could you say this is your final answer? I guess you could, but I think we can make this simpler because there are some other trig identities that are going to help us with this. I'm going to split that cosine squared in the denominator into 2 separate pieces. So the first one's going to be sine of x over cosine of x, and now I'm going to multiply by 1 over cosine of x. And the reason I've done this is now I can turn the sine x over cosine x back into tangent, and then the 1 over cosine becomes secant. And so, yes, the derivative ends up being a product of sorts here, but so of the other two. The first two technically were cosecant, and the other was secant. One quick note as I'm looking over here, that negative sign back on the previous one should be carrying down to our final answer. So it actually should be negative cosecant squared of x, not positive. So I'm put that in red just to remind you to fix that. So back to the original one we're doing here. Y prime should be here, tangent of x times secant of x. And so for the last example here for the final one is cosecant. So go ahead and take another pause on this video and find the derivative of cosecant. And here is the work for the derivative of cosecant. So once again, very similar process. When you do low d high, you get half of it basically wipes out because of the derivative of the constant. And be sure, as you heard in my previous example, that negative sign, I'll put it in red here just to emphasize it, carries down throughout the problem. And so yes, this derivative is going to be negative cotangent x times cosecant of x. So that summarizes all 6 of the trig functions now. So let's take a look at them all together. So you have your sine and cosine that we talked about, and then these new 4 derivatives. So tangent is secant squared, cotangent's negative cosecant, and then we have those final 2. There's going to be all sorts of different ways for you to look at this and find patterns, find relationships, and ways to remember. One thing that I always find that's really easy that helps me out is the derivatives of all of the quote-unquote co-functions. That's cosine, cotangent, cosecant, are all going to have derivatives that have a negative sign in front of them. So right away, in terms of mentioning earlier, remembering which ones have the negatives and which ones don't, a good suggestion is if you're taking the derivative of a quote-unquote co-function, it's going to have a negative sign in front of it. There's a reason why mathematically that's happening, but I'm not going to go into that in this video here. So that concludes all of the different trig derivatives. You can now try this in additional problems. Be sure to check the lesson plan, or you can also check below on this video for a link that has additional examples if you would like some additional derivative practice problems that you would like to be walked through that use these different rules. But other than that, that concludes all of the product and quotient rule stuff. Thanks for watching.